In this exercise, we'll look at the code that is written to make our Arduino blink. So we'll open the blink program. If you don't have that open already, you can click on File, roll down to Examples, keeping your mouse in that track, go to Basics, and from Basics to Blink, and that will open up another sketch for us to program on. And I'll just delete the one behind it. Don't save. There's don't save. So now we have the same blink code. What we want to do is look at how this code is organized and start to learn what we need to do to make our own programs. First of all, let's read what's at the top. There's a lot of good information there, and you shouldn't ignore that. So I see the name of the program, and then right after that, the description of what it does. It turns an LED on for a second and then off for a second, and it repeats it. And then it goes into more detail, saying that there's other devices, Arduino devices, that use pin 13, the output pin 13, that also has an LED that corresponds to that pin on the board. So at this time, I suppose, pin 13 is turning on and off, and this LED is turning on and off. And by the way, we're using the Key Studio Shield. Okay, and we'll continue. I don't think we need this information, so I'm going to drop it for now, and you can do the same. Oh, and since we're going to modify this, let's take over this. Well, I'm going to do File, Save As. By the way, you shouldn't be able to save Blink, the original program, back into its original space. So this looks like it's in my documents in Arduino. That's good enough for me. So I'm just going to rename this My Blink, and no spaces. And I'll give it a version number 1 because I may change it. And I'll click Save. I see it's back, and it looks like it has some updates for libraries. I think we'll do that later. For now, let's take a look at our code. So I did save it with a new name, and I want to modify this. Now this is the attribution to whoever worked on it originally or last, and we'll keep the last one, but I'll delete the rest of this all the way down to the bottom, and I'm going to change this to match our class conventions. What I like to do is have us have the modified date, then who did it, and then after that the type of modification that was made or that's being worked on. And there we are. So this looks good. Okay, so they have at the beginning of this comments a / or asterisk. So that says everything from there on is going to be, well, comments, and it's going to be ignored by the compiler. If I were to disable this one by commenting it out, I think I can do that. Can I do that? Nope. Looks like I have to actually take that away. Okay, it did do it. So what I've done is I've made it so all of the program is commented out, which means if we were to try to compile this, nothing would happen. So I'll put that back. And once I put it back, it should allow the code to show up as programmable. So this does a block of code. The / asterisk, and then the / asterisk turns it off. Well, it looks like it needs to be an asterisk /. There we go. So that's for a block of code. For a single line of code, it looks like it's just 2 /. Okay? And we have 2 parts of our code, 2 sections. The setup function, which runs one time. So anything that needs to be prepared but only needs to happen once, that code can be put in here. Any code that needs to run continuously or as the body of the program is down here in the loop. And then you can make up other functions down below. Okay, so we have our a statement saying this is going to be void. The function is set up with parentheses. We've seen that before. And the void just simply says that nothing is going to be returned, so it doesn't plan for that. But here's something that's new for us. and that is the beginning and the end of this function is denoted by curly braces. So we have an open curly brace and an end curly brace, and these have to match. And we have the same for our loop. So what really happens in this code? Looks like there's a function called pin mode, and there's a value that's in the variable LED built in. Well, I remember this being just a static value. In other words, LED built in will always be equal to 13 unless it gets modified. And so this is telling pin 13 to be an output. Okay. And then so that enables the pin, just pin 13, to be an output as opposed to an input or an unknown state. Now the next part, the loop, it has our first command that enables an output. So it says digital write, and notice that the first word in this function, first letter rather, in this function is a lowercase, and the write is a capital. All of our functions and our variable names are case sensitive, and that's a convention that we're going to follow. Lowercase to begin with. Any other words that are concatenated to it or added on, we'll capitalize those. And in that function, we're going to send that same pin 13 in the variable of LED built in, and we're going to turn that pin's value to high, and the comments agree. Turn the LED on high. High is the voltage level. It waits for a second. Well, if it delays 1,000 of these, then each one of these must be a millisecond, 1/1000th. So it waits 1 second, then it does another digital write to that pin 13, a low, which turns it off, and it waits yet another second. Okay, and that is what it's doing. Oh, my board looks a little sketchy. I put some squares of electrical tape over the top of the LEDs, especially this power one. It was just so bright. It wasn't only blowing out my camera, but it was making it hard for me to look at. So feel free to do the same. What I want to do is change some of the values in here and learn more about what's going on inside this Arduino from the sketch. So what I'd like you to do is make the on time and the off time half as much. So if I click here and turn this 10 into a 5, so now it's going to be off 500 milliseconds and then back on 500 milliseconds. Let's see what that looks like. All I have to do is go up here and click upload. It stops this. Watch the LEDs that flicker. Those are the transmit receive LEDs. After it compiles, it should send it right out to this board. And I'm looking at my code, and again, I have no board selected. Well, let's go find out if we can change that. So the board is supposed to be an Arduino Uno. So I'll select that. Oh, I remember. I closed and then reopened this program. That's why it went away. And then what else is true about this? I'll click this and still fails. It says it's done compiling. Failed to upload. No upload port provided. Well, that sounds like we need to set a port as well. And you'll remember from an earlier exercise that we have to go down to port and choose where the Arduino is. Now, one thing I've liked about the recent versions of the IDE, if it can see the Arduino on a port, it will name it or label it. It won't auto-select it, but at least it'll name it. So I'll choose that as port 8. And now when I look down here, I can see Arduino Uno on COM 8. Well, good. Now let's try once more to upload this. I click it. It's doing the compiling. Compiling is done. It's done the uploading, and the uploading is done. Excellent. I like this new interface. It's a lot cleaner than having all of the messages scroll up. Okay, and let's take a look at our board, see what it's doing. Well, it seems to be going twice as fast. What I'd like you to do is play with these numbers, change them. Change the duty cycle, so instead of half on or off, change it so it's maybe 1/10 of the time on and the rest of the time off, and make it go faster. See how fast this, back to the 50% duty cycle, how fast can you make this blink and still tell that it's blinking. In other words, I know I can make it go 1 millisecond and the LED will just be dim. It will be just maybe half as bright because it's only on half the time, but I can't see it flash. Now, I want you to see what's the lowest number you can have and still detect or recognize that that's actually blinking. And that will be the rest of your exercise.